Hello friends, welcome to this video. So here we will learn about solving some numerical problems based on motion. Okay, so I have written some questions here. You can see numerical problems. So we'll try to solve 5 questions in this particular video. Up to which question? Up to question number 5 we can solve. And the rest of the questions will be solved in another video. So let us start with the first question. Okay, the first question is, you see the question, consider a body in motion along a straight line. Okay, you have a body moving in a straight line. If its position at 9 p.m. is x equal to 60 meters, and at 9:05 p.m. It is x equal to 75 meters. Find the displacement between 9 p.m. and 9:05 p.m. Okay, so how much displacement has the body got in 5 minutes? That is what we have to calculate. So let us go to the calculation. So just give me a moment, please. Okay, I hope you can see my whiteboard. So the question is, at 9 p.m., the body is at x equal to 60 meters, and 9:05 it is at x equal to 75 meters. Okay, so the motion is it is a straight line motion. Okay? It's a straight line motion. At 9, so suppose it's x equal to 60 meters and x equal to 75 meters. Okay, so this is at 9 p.m. and this is at 9:05 p.m. So the question is, what is the displacement? Displacement means how much position has been changed by the body. I mean, the position of the body has been changed by how much distance. That is what we need to calculate in 5 minutes. So it's for a straight line motion, very simple. So subtract 7 from 75, subtract 60. Okay, and the answer is 15. Okay, so it is 15 meters. So in this 5 minutes from between 9 p.m. to 9:05 p.m., the displacement of the body is 15 meter. This is a straight line motion. Okay, so in straight line motion, it is quite easy to calculate how much distance or what is the displacement of the body in a given amount of time. So here the answer is quite straightforward. The answer is 15 meter. Okay. Now let us check the second question. I show you the second question. Okay, here you can see the second question. A car covers 30 kilometers at a uniform speed of 60 kilometers per hour, and the next 30 kilometers at a uniform speed of 40 kilometers per hour. Find the total time taken by the car. Okay, so a car which covers 30 kilometers at a uniform speed of, first 30 kilometers it covers at a uniform speed of 60 kilometers per hour, and the next 30 kilometers it covers at a speed of 40 kilometers per hour. So what is the time taken by the car? Okay, so let us discuss this question. So second question. So first 30 kilometers, first 30 kilometers it has covered with a speed of 60 kilometers per hour. Next 30 kilometers it has covered with a speed of 40 kilometers per hour. So we have to calculate the total time. So again, what is time? So in this question, we have to use the concept of distance distance is equal to time multiplied by velocity or speed. Okay, so what is in the first case, what is the distance? That is 30 kilometers. Time consider t1 multiplied by velocity is 60 kilometer per hour. Okay, so it is distance is 30 kilometers, so 30 over 60. So this should simply give us t1 time is equal to 30 over 60 hour, which is 0.5 hour. Okay, so this 30 kilometer, the car covers in 0.5 hour. Okay, so the next secondly, what is the what will be time t2? Then time, in order to calculate time t2, we have to just divide 30 by 40. Okay, so 3 divided by 4, which gives us 0.75 hour. Okay, so what will be the total time taken in that case? Total time taken is very straightforward to calculate. T1 plus T2 is equal to 0.5 plus 0.75 hour. Okay, so how much will it be? It will be 1.25 hour. Okay, so 1.25 hour you can also express in minutes. So 1 hour means it is 60 minutes plus 0.25 hour means it will be 15 minutes. So 60 plus 15, this would simply give us 75 minutes. Okay, so the total distance the car would take 75 minutes to cover the total distance. Okay, so this is how you can solve this question. First 30 kilometers in 0.5 hours and the next 30 kilometers in 0.75 hours, and total time would be 75 minutes. Okay. Okay, so let's check the next question. So I show the next question, which is, okay, so next question seems quite simple. Convert 54 kilometer per hour into meter per second. Okay, 54 kilometer per hour into meter per second. So how can we do this type of conversions? Okay, so 54 kilometer per hour. 54 kilometer per hour into meter per second. So how we can do this? So 1 kilometer means you have to multiply 1000 to get meter, and hour means second. So we have to divide by 3600. Okay, because 1 hour is equal to 3600 seconds. Okay, so now just divide. So by 18, it is 2, this is 3. So 30, it's 15 meter per seconds. Okay, so if you convert 54 kilometer per hour to meter per second, that would simply give us 15 meter per second. Okay, so there is another way to do this calculation, which is, I think, a simpler way. So whenever you are given such questions that convert some given kilometer per hour into meter per second, so suppose here it is 54, then do this thing. Multiply that number by 5 divided by 18, and that would give us, that would simply give us meter per second. Okay, so 54 kilometer per hour, so multiply by 5 by 18, so we will get it will be 315 meter per second. Okay, so this way also we can calculate, we can convert kilometer per hour into meter per second. Okay. Okay, I hope you have understood this answer also. So let me show you the next question. Okay, so now it is about calculation of acceleration. Find the acceleration of a car if its velocity is 60 kilometer per hour at 5:15 p.m. and it increases to 80 kilometer per hour at 5:17 p.m. Okay, so basically in 2 seconds, if I can annotate here, so 5:15 p.m. and 5:17 p.m. So in 2 minutes, the velocity of the car has increased from 60 kilometer per hour to 80 kilometers per hour. Okay. So how can we do the calculation? So acceleration is simply change in velocity. Okay, acceleration change in velocity divided by time. Okay, so change in velocity here, it's 80 minus 60. Okay, how much velocity change has been there? 20 kilometer per hour divided by, it's 2 minutes. Okay, 2 minutes. Okay, 20 kilometer per hour by 2 minutes. Let me show you this calculation in the whiteboard. Okay, so we have already done the basics. So 20 okay, so it was 20 kilometer per hour by 2 minutes. Okay, so it is basically 10 kilometer per hour divided by minutes. So now you see, in one case we have hour as the unit of time and we have minute as the unit of time. So what we do here is that kilometer per hour, we will keep it as it is. Divided by 1 per minute means it will be how much? 60, 1 per hour. Okay. So 1 by minute, because 1 hour means 1 hour means 60 minutes. Okay, so 1 by 60, it would be hour. So 60 would go to the numerator. Okay, like okay, let me write it here. 1 hour is equal to 60 minutes. So it will replace this value. So 60 would go to the numerator. So multiply 10 and 60. It would give us 600 kilometer per hour square. Okay, so the unit would be kilometer per hour square in this case. So the value will be 600 kilometer per hour square. So this is the value of acceleration. Okay, this is the required acceleration that we need to calculate. I hope you have understood this questions, this answer. So acceleration is nothing but the change in velocity divided by time. Okay, so let us go to the next question. Okay, so yeah, okay, so so consider an object moving up an inclined plane. Its velocity changes from 20 centimeter per second to 10 centimeter per second in 2 seconds. What is the acceleration? Okay, so basically a body is moving up an inclined plane and its velocity changes. Actually, there is a decrease in velocity from 20 centimeter per second to 10 centimeter per second in 2 seconds. So how can we calculate its acceleration? Okay, so let us go back to the whiteboard and explain let me explain the problem. Okay, so an inclined plane, how we can draw an inclined plane? Something like this. Sorry, I'll try to draw it better. Suppose this is the surface and we have an inclined plane. Okay, these are not very straight lines. And okay, this is a body, suppose. Okay, this side is some body, maybe a box. Okay, so it goes up the inclined plane. Okay, it was initially moving with a speed of 20 centimeter per second, and later its speed decreases to 10 centimeter per second in 2 seconds. Yeah, in 2 seconds. What is the acceleration? So again, it's quite simple to calculate. So acceleration, suppose A. Okay, it is nothing but the change in velocity. Okay, change in velocity divided by time. So how much change in velocity is there? So 20 centimeter per second initial velocity and 10 centimeter per second final velocity. So 10 minus 20 divided by in how much time? 2 seconds. So velocity is centimeter per second divided by 2 seconds time. Okay, so it will be minus 10 by 2 centimeter per second square. So it would be minus 5 centimeter per second square. Okay, so this is the acceleration. So what we get to see here is that the acceleration has got a negative sign. Okay, here the acceleration is not positive, but it has got a negative sign. So what does it mean? It means that this acceleration of the body, okay, is in a direction opposite to the direction of motion. That means along the direction of motion, the acceleration of the object is decreasing along the direction of motion. Let me write it down. The acceleration is decreasing with time along the direction of motion. And that is why acceleration in this case has got a negative value. Okay, so I hope you have understood this problem, the concept behind this problem. I hope, friends, this is up to this much we are going to learn for now, and there will be more problems which will be mainly graphical questions. I mean, questions based on some graphs. So we'll learn to analyze those graphs, and we'll solve those questions in our next video class. So thank you very much for watching. If you have liked the video, if you have liked the lesson, please like the video, do subscribe this channel, and also share it with your friends. So thank you very much for watching, and I will see you in the next video. So thank you again.